Hello and welcome to this lesson. In this lesson, we want to look at how we draw structures of organic compounds when we have been given the UPAC name. Before we can even look at how we draw these structures, please don't forget to subscribe to our YouTube channel, that is Zuluba Consultants, and the Facebook page, Zuluba Consultants, for this and more videos. Let's look at now the question that we have. We have been asked to draw 2, 3, 5, 6 tetramethyloctane. Now, when we have been asked to draw this structure, there are some key elements that we need to know from the name that we have been given. Let's start with the first one. This tetra suggests that 4 of the same substituents are attached to that compound. So tetra means 4, so it simply means 4 substituents are attached to this compound. Now, what are those 4 substituents? The 4 substituents are the 4 of this compound here, which is a methyl. Now, from our understanding of chemistry, we know that meth means 1. So, we have a prefix that is giving us that the methyl compound or the methyl substituent has been attached to this long chain. So the long chain is the parent. The long chain is the parent. And then we have the last letters, that is the ANE. It gives us the suffix of the compound. Now, the suffix tells us the bonds that is between carbon-carbon bond. So it tells us what type of bond is linking the carbons in the parent compound. So let's start now to see how we draw this structure. So the first thing that you need to know is to look at the parent and identify how many compounds are in the parent. Now, we have the list of a number of carbons that are attached to the parent. So when you look at oak, it simply tells us that we should have 8 number of carbons. So we are going to draw 8 carbons. So we have drawn 8 carbons there. So after we have these 8 carbons, these are representing the parent, which is oak. Now, after we know that these are representing the parent, we are going to number these carbons. 1, 2, 3, 4, 5, 6, 7, 8. So after we do the numbering of these carbons, we can now put the prefixes, that is the substituent, or the branches that this bond or that this compound has. So the first substituent is on position 2. So they are saying the first substituent should be on position 2. And as we said, meth means 1 carbon. So because it's a methyl, it simply means we have a CH3, which is attached to the parent. So the first CH3 should be attached to the parent on position 2. So we'll put the first one here. Then they tell us that the next one should be on position 3. So we'll put the other one here. And then the next one should be on position 6. Position 5 rather, before position 6. So we have put these substituents on position 2, position 3, position 5, and position 6. Now remember what we said. Tetra is helping us to understand that the substituents should be 4. And as you can see, we have put 4 substituents of the same family. So after you do that, you simply now complete the number of hydrogens that each carbon should have. Now remember, a carbon can only have 4 bonds as the maximum number of bonds. So this simply means that each carbon will check and see how many hydrogens should be added to that carbon. So the first one, it has only 1 bond. So this simply means it can accommodate 3 hydrogens so that it has now a complete 4 bonds. The second carbon has 3 bonds on it. So it only needs 1 hydrogen for it to have 4 bonds. The third one has 3 bonds, so we'll add 1. The fourth one has 2 bonds, so we'll add 2 hydrogens. Then the fifth has 3 bonds, we'll add 1 hydrogen. The sixth will add 1 hydrogen. The seventh one will add 2 hydrogens. Then the eighth one will add 3 hydrogens. So if we do this, then we have correctly interpreted the name that we have given into a structure. So what do we need to know in summary when we are drawing the structures of a given name? First of all, identify the parent. The parent will tell you the longest chain. In this case, the parent was oct. This simply means we'll have 8 carbons on the longest chain. Second, you look at the suffix. The suffix will tell you the type of bond that is between the carbon to carbon on the longest chain. So in this case, the suffix, it is ANE, which is simply suggesting that there are single bonds in the longest chain. The prefix tells you the substituents or the branches that this compound has. And then that substituent will always come with the position at which that substituent is. In our case here, the position were 2, 3, 5, and 6. Now, because we have the same substituent, the same branch, then that's why we had tetra to represent that all these 4 are of the same substituent. Please, we hope you have enjoyed this video, and don't forget to subscribe to our YouTube channel for this and more videos.